Hello everyone, I'm Maitraye and I'm going to talk about our research on enhancing accessible pattern design practices among blind weavers. In this project, I worked with Darren, Gergle and Anne-Marie Piper. So I'm going to start with a story. This is a story of Lisa, an older adult, legally blind and nerve-deaf weaver. Lisa lives in an assisted living facility where she works in a weaving studio with other blind residents and their sighted instructors. For the past 9 years, Lisa has made many different woven products like tote bags, dish towels, runners, and so on. The image on this slide shows a fabric with blue, green, and yellow yarns that Lisa was working on. Now, Lisa is a disabled artist who enjoys working in this community weaving studio and making woven products that she can sell and give to her family and friends. She is also a proficient musician and songwriter, and she can play 67 different instruments, including harp, flute, and piano. During my interview with her, Lisa talked about the value of her arts to herself and others. She said, "Our music, our weaving, our art is a part of our lives. As a visually impaired person, from spinning to knitting to crocheting to weaving, I want to keep this art alive so that if you go to a cultural center, you see my legacy. Whether you knew my name or not, my name is in my work. This is who I was." Lisa's comment illustrates how disabled artists like herself have produced rich and innovative arts over the years that celebrate disabled ways of knowing and being. But where does Lisa's story fit in within the extensive literature on making and design that has traditionally highlighted experiences of makers who are younger, able-bodied, well-educated, and affluent? Recently, scholars have critiqued that certain communities, particularly those who do manual, non-technical handwork like fiber arts, have been under-recognized in mainstream design scholarship. Moreover, many design stories tend to position disabled people as non-designers and able-bodied people as designing for them. As part of this discourse, accessibility researchers have started talking about how to make making and design more accessible. Researchers suggested that physical makerspace and software and hardware tools for making should be improved to support disabled people. At the same time, researchers have also emphasized that making activities can foster creative expression, independence, and empowerment among disabled people. Much of this work focuses on supporting disabled individuals in making independently. However, we still do not know much about community aspects of accessible making. So, in our research group, we have been focusing on understanding how ability diverse groups that involve blind and sighted people take part in collaborative making within a community setting. For the past few years, we have partnered with a community weaving studio that is supported by an assisted living facility for adults who have vision impairments and other chronic health conditions. And this series of work started with our CHI 2020 paper. We presented how blind weavers like Lisa are empowered as designers in this community, and they, along with their sighted instructors, co-create an accessible space for making. In the next study, we explored what roles technologies might play in accessible making. We designed an audio-enhanced physical loom called Melody that provides auditory feedback when weavers act upon different loom components for weaving. And the study I'm going to present now focuses on accessibility in pattern design, which is the very first step of the weaving workflow. So first, to understand accessibility in pattern generation, we conducted formative interviews with 14 blind weavers and 3 sighted instructors. From these interviews, one thing that stood out to us was how blind weavers used weaving as a storytelling tool and expressed their artistic intent and lived experiences through patterns. And to some weavers, music in their surrounding environment evoked new imaginations about colors, textures, and patterns, which they understood as the rhythm of weaving. A salient example of this is the sound weaving project, where blind weavers attach to their woven pieces music-related objects like cassette tapes and guitar strings, or things that made sound when touched or rubbed, like bells or aluminum foil. For example, the image here shows a tapestry with some sound-related objects woven into the fabric. We also found that blind weavers often try to perceive patterns on the woven fabrics through verbal explanation or hand-over-hand guidance from sighted instructors. For example, one blind weaver said, "The sighted instructor will take my fingertip and use it as you would use a pencil. And she will say, 'See how this diamond connects, how this goes up and then down.' She moves us through the pattern." So this way, blind weavers can perceive the pattern that finally appears on the woven fabric with guidance from the instructors. But still, blind weavers participation in the design phase of a project remains limited because the software for editing patterns are graphics heavy and not compatible with screen readers. As shown on the image here, that includes a screenshot from a software called Fiberworks. But pattern designing is a particularly important step in weaving because here, weavers can engage in a form of algorithmic thinking as they determine the look of the resultant fabric by changing numerical sequences for systematically interlacing threads, and they prepare a 2D grid-based instruction set called the weaving draft. So the lack of accessibility in pattern drafting tool really limits blind weavers' engagement in collaborative design. To address this, we developed a pattern designing tool called Simphony to enhance blind weavers' understanding of draft patterns. Simphony includes a tablet application which presents the weaving draft using spoken audio and sonification techniques. For example, changing audio parameters like pitch, volume, and timbre or types of musical instruments to represent the numerical weaving sequences and colors. For example, the threading sequence that's highlighted on this slide is 1 2 3 4 1 2 3 4 repeated multiple times, and on Simphony it could sound something like this. In addition, a wooden grid overlay is placed over the tablet to help weavers navigate the grids on a weaving draft and tap on cells through the holes of the wooden grid overlay. And weavers can also use the wooden grid as a standalone device and create sequences by arranging small wooden blocks on the grid. We conducted 8 design exploration sessions at the community studio, where blind weavers and sighted instructors interacted with the system to create and perceive different weaving patterns. So we noticed that blind weavers learned to attend to the auditory cues to keep track of the system state and identify order and repetition in patterns. The musical and tactile representations also helped them in learning complex weaving concepts. For example, a blind weaver said, "Sometimes I get confused with numbers for weaving sequences, but if this tool was in front of me, that would have stayed in my mind as a mental loop." This made everything come alive. Our findings also informs our understanding of asymmetry in meaning making between blind and sighted collaborators. For example, sighted people tend to perceive patterns as a whole and visually track emergent shapes in the pattern. On the other hand, blind weavers in our study perceived a pattern sequentially by taking in information cell by cell on the grid and cognitively aggregating this information into a global shape. As the image on this slide shows a blind weaver sequentially tracking the wooden blocks arranged in a pattern using both hands simultaneously. The exploratory procedures blind weavers adopted, including their direction of hand movements, their experience with disability and tactile perception ability, their musical and mathematical knowledge, all these influenced the way they understood a shape. And sometimes their understanding through sequential exploration did not align with how sighted instructors described it. For example, the shape that sighted instructors viewed as a diamond, a blind weaver described it as a cross. However, none of our participants characterized the sighted way of understanding a pattern as the only correct approach. Instead, blind weavers and sighted instructors co-constructed a multiplicity of meanings. Blind weavers demonstrated to sighted instructors how they tracked a shape by moving fingers over the tablet cells. Sighted instructors, in turn, guided the fingers through verbal explanations and hand-over-hand support along the contour of a shape they perceived visually. This way, both collaborators recognized how the same pattern can have multiple interpretations to different individuals and yet be part of a shared meaning they built together. Based on this, sighted instructors also paid attention to how individual weavers reacted to various audio-tactile cues, and they tuned their teaching strategies accordingly. As instructor Sarah explained, each weaver is thinking about a pattern from a different perspective, and Simphony was very helpful in uncovering those different perspectives. Thus, the musical and tactile representations in Simphony provided additional affordances that sighted instructors could use to supplement their verbal guidance and scaffold learning of the underlying weaving mechanisms for blind weavers. Beyond this, Simphony also prompted blind weavers to reimagine how music and weaving can come together in new ways. For example, Adam, a weaver with low vision, created a threading sequence inspired from the melody of Happy Birthday to You. Let's listen to a clip. So this way, integrating technology could also open up new avenues of creative expression and aesthetics for disabled artists by enabling a fusion of different art forms like music and weaving. As one blind weaver said, it could be done like a musical where you are weaving and the song is turned into a cloth. Please read our paper for more details of our findings and reflections around how we might integrate technologies into traditional forms of making, such as pattern design, to transform learning and access in these practices. Thank you.